Hello, Algebros. Today we are going to be talking about the characteristics of quadratic functions and also cubic functions, but we're going to start with quadratic functions. So we're going to really look at the graph of these functions and really just dive in to see what the different parts are. All right, so the vertex of a quadratic function or quadratic graph is the turning point of the graph, or the highest point or the lowest point, or the middle of the graph. You may have it here, it describes several different ways, but the vertex is the turning point of our graph. And what I mean by turning point, if we were to hop on this line roller coaster, we're going to go click, 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 and when we get there, we change directions and we're like, whee! Okay, so the vertex is that point where we change directions, or the middle of our quadratic function. Okay, so the middle point there, we can see we have an x value of 3 and a y value of 7. So we need to type this in as an ordered pair. So x value of 3, y value of 7. Now AOS stands for axis of symmetry. And that axis of symmetry is a vertical line that cuts our parabola in half. It also goes through the vertex. So if we're talking about a vertical line, we need the x value, and our x value is 3, so we need to write the axis of symmetry as an equation, x equals 3, because it represents a line. I also want you to draw that line, so I didn't make my window big enough to see what my clicks are, but I click on Insert, Shapes, and I select one of the line tools, preferably the one with arrows on both ends, and I draw it right down the middle. Now you can change the weight of that line so you can see it. If we were drawing it in person, I would make you dash it, so if you want to put dashes on it, you can do that as well. So maximum or minimum, if the graph has a maximum value, it's going to have that hilltop or that mountaintop. If it has a minimum value, it's going to be a valley. So if we look here at our graph, we see we have a hilltop. So this graph has a maximum. Now x-intercepts are kind of one of those, they have lots of disguises. They can be represented by a lot of different words, and they all mean the same thing. So when I'm asking for the x-intercepts, what I'm really asking for is the solutions. I'm also asking for the roots, and I'm also asking for the zeros. So when we were solving quadratic equations in our last unit, what we were really finding was the x-intercepts. We were finding the zeros. We were finding the roots of the equation. So when it asks for x-intercepts, it could be asking for all of this. So if it asks for the solutions, it's asking for the x-intercepts. If it's asking for the roots, it's asking for the solutions. If it's asking for the zeros, it's asking for the x-intercepts, vice versa, all the way around. The x-intercepts like to disguise themselves as different words. So if we look here at our graph doesn't cross the x-axis at a really pretty number, so you are going to kind of estimate, make your best guess when it doesn't cross at a pretty number. So if I look here at my left x-intercept, I don't quite cross at 0, but I definitely don't cross at 1. I'm much closer to 0, so I'm not halfway. So my first x-intercept is probably going to be like 1/4, I would say. You could also do it as a decimal, so 1/4 as a decimal would be 2500. Okay, but that's not our only x-intercept. We have 2 x-intercepts. So if we look at our right x-intercept, you can see that we're past 5, but we're not quite to 6, but we're definitely over halfway. So if we're 3/4 of the way there, you could write 5 and 3/4, whereas a decimal, it would be 5.75. You could also write that second one as an improper fraction, which is what you are going to see more often than not, which would be 5 times 4 would be 20, plus 3 would be 23 over 4. So you don't have to have all of these options listed. These are the 3 different ways that you could write your answer, and it would all be correct. The y-intercept is pretty self-explanatory. It's where our graph crosses the y-axis. So our graph crosses the y-axis right at about -2. So we're going to have y equals -2. Now, domain is where the graph exists along the x values. So this graph is going to continue to get wider and wider, and there's no limit to how wide it's going to get. So it can equal, or at every x value, this graph will exist, because this graph is going to go on forever and ever. So because at every x value this graph exists, our domain, which again are the x values, is going to be, you can say all real numbers, or you can say -infinity to +infinity, and you're going to have to go to the equation stuff to get that infinity symbol. So you can say -infinity to +infinity, and to get to the infinity sign, you go insert, symbols, an equation, and then all the math stuff pops up. Our range is the y values. So where does this graph exist vertically? Well, it doesn't exist past a y value of 7. You can see that the red line does not go past the y value of 7. So that's the top point of this graph, but it exists everywhere else below that forever and ever. So our y values are going to be y less than or equal to 7. So our y values are less than or equal to 7. And to get the less than or equal to, you have to go to insert, symbol, equation, and then you click it, y less than or equal to 7. Okay. All right, let's look at the next one. All right, our vertex, remember the vertex is the turning point or the center of the graph. So our turning point is right here, and we have a x value of -1 and a y value of +3. So our ordered pair would be -1, +3. Our axis of symmetry, remember, is going to cut that graph in half, and I want you to actually insert that. So we need to go to the line tool. So you go insert shapes, select one of the lines. Again, preferably the one with arrows on the end. Let's make that a little bit thicker, and let's give it some dashes so it looks mathematically correct. So our axis of symmetry is this vertical line that cuts our graph in half. So when we write a vertical line equation, we're only concerned about the x value. So x equals -1. And again, you might notice that our axis of symmetry, x equals -1, is the same x value from the vertex. So does this graph have a maximum or a minimum? Remember, the max has a mountaintop, the minimum has a valley. So if we look, we're in a valley here, so this graph has a minimum. Looking for our x-intercepts. Remember, x-intercepts are the solutions, they're the roots, they're the zeros. Looking at this graph does not cross the x-axis. So there are no x-intercepts. So what this would look like algebraically if we were solving it, these would be those imaginary numbers. So when you're solving a quadratic equation and you get a negative square root, this is what the graph would look like. They're imaginary solutions. They don't ever cross the x-axis. They're just floating out in space. Our y-intercept, where the graph crosses the y-axis, the graph crosses at +5. I would prefer you write these as an ordered pair, but you can write y = 5, that's fine. Because we're really talking about a point on a graph, we're not talking about a line, we're talking about a point. So I prefer the ordered pair, but y = 5 is fine. The domain, remember the domain are the x values. Where does this graph exist with the x values? Well, this graph is going to continue to get wider and wider as it goes on forever and ever. So it's going to exist at every single x value that you could think of. So all the numbers, so you can say all real numbers, or you can make it mathy and go insert symbols, equation, negative infinity to positive infinity. And this is called interval notation when it kind of looks like an ordered pair, but it represents something else. So you can write it either one of those ways. And then the range is where this graph exists with the y values. So notice this graph doesn't exist below the y value of 3, but it exists above that. So all of the numbers that are bigger than y = 3, this graph exists on. So our range would be y is greater than or equal to 3. And to get the greater than or equal to, you have to go to insert symbols, equation, and you can see it listed there. Y is greater than or equal to 3. And that would be our range. This graph doesn't exist the y values that are less than 3. So it only exists when y is greater than or equal to 3. All right, you have a few more to do on your own. My next video will be the characteristics of a cubic function. So stay tuned. Happy mathing.